Hello and welcome to the lecture on 5.1. Today we're going to talk about the unit circle. Start with a definition. The unit circle is the circle with radius 1 centered at the origin in the xy plane. Its equation is x squared plus y squared is equal to 1. Now I cannot stress this enough. It's important to note that it's in the xy plane. It's very important to note because in the next video, we're going to talk about the unit circle separately, where I'll explain how to understand the unit circle and the values that are on the unit circle. If you don't understand that it's in the xy plane, then it becomes very confusing. Okay? So, if we were to graph the unit circle in the xy plane, we would have the center here at the origin, and the radius would be 1. So we would know here this is 1, 0, because the radius is 1, 0, 1 here, negative 1, 0, and 0, negative 1. We can start here. Since we know the equation of the unit circle is x squared plus y squared is equal to 1, we can figure out which points are on the unit circle. Now, we'll need to check, but we can do it. We can determine if a point is on the unit circle or not. Which of the following points are on the unit circle? A, 0, negative 1. B, 1 half, 1 half. C, 1/4, square root 15/4. Or D, negative 1, 2. So we need to determine which ones are on the unit circle and which ones are not on the unit circle. How do we do that? Well, we have an equation, remember. X squared plus y squared is equal to 1. Each of these is a coordinate. First value in the ordered pair is the x value. The second value in the ordered pair is the y value. So I'm going to take my x value, plug it in for x, take my y value, plug it in for y, and see if it satisfies this equation. If this equation is satisfied, meaning that the equation is actually true, then that point is on the unit circle. So here, 0 squared plus a negative 1 squared, we get 0 plus 1 is equal to 1. So this point is on the unit circle. That should make sense because it's right here, and I've already plotted it on the unit circle. How about 1 half, 1 half? Well, we plug in 1 half for x, 1 half for y. We get 1 half squared plus 1 half squared. This will be 1/4 plus 1/4. And is this equal to 1? 1/4 plus 1/4 is 1 half. 2/4, but it's the same thing as 1 half. Is 1 half equal to 1? No. So this point is not actually on the unit circle because it doesn't satisfy this equation. How about 1/4 square root 15/4? So we plug in 1/4 for x. Plug in square root 15/4 for y. And is this equal to 1? Because that's what the equation says it should be equal to. Well, 1/4 squared is 1/16. Square root of 15 squared is 15. 4 squared is 16. So we would have 1/16 plus 15/16 is 16/16, which is equal to 1. So we can say that 1/4 square root of 15/4 is on the unit circle. That would be right about here. Part D, negative 1, 2. Now this one should be pretty obvious. This one's not going to be on the unit circle. Negative 1 squared plus 2 squared, that's equal to 5. Is this equal to 1? No, it's not equal to 1. This is not on the unit circle. Each coordinate of every point on the unit circle will be less than or equal to 1. These are the maximum values. 1 is the maximum value any point, any value in an ordered pair can actually take. All right, try one on the accompanying worksheet. Give an example of a point that's on the unit circle. I would say that you need to avoid at least these points where you have plus or minus 1, 0, and 0 plus or minus 1. At least avoid these points. You should also avoid the other points that are on the normal unit circle if you've seen the unit circle before. Try to figure out a point that is on the unit circle. Obviously, also don't use this point, because that one's clearly on the unit circle, as we just found out from the previous example. Terminal points on the unit circle. Let's start by talking about what terminal points actually are, and we need to understand how we get to a terminal point before we can actually talk about what they are. Let t be a real number. If t is greater than or equal to 0, travel t units along the unit circle, starting at 1, 0, in the counterclockwise direction. If t is less than 0, travel the absolute value of t units along the unit circle in the clockwise direction. We arrive at a point pxy on the unit circle. The point pxy is called the terminal point determined by t. So what we're talking about here is this. We have our unit circle, and if t is greater than or equal to 0, we start here. Just remember, in previous sections, the initial side of an angle was all in standard form is on the positive x-axis. So that's where we start when we start traveling around the unit circle t units. So if t is greater than or equal to 0, we're going to travel in this direction, counterclockwise, and we're going to end up here. So we travel this distance, t. If t is greater than 0, of course, greater than or equal to 0. Now this point, pxy, this is called the terminal point. This point is determined by t, because if t is shorter, we get a different point. Now, suppose that t is less than 0. Remember, when we have a negative angle, we move clockwise, not counterclockwise. So again, standard position, we start with the initial side at the positive x-axis, and we move clockwise. So we go this direction. The absolute value of t units, because t is negative. So we would move down this way, clockwise, hit this point, which is pxy. Now again, this is the terminal point determined by the value t, and it's negative, which means that we move clockwise, not counterclockwise. You have to also remember that we move along the unit circle. We're not doing an angle here, we move a distance along the unit circle. That might remind you of a measure of an angle. Remember that when you move along the unit circle, because the unit circle has radius 1, we're talking about the radian measure of this angle. We're going to do an example and show you sort of what I mean here. So suppose we have the unit circle. Suppose that our t is equal to pi. Remember, pi is 1/2 of a circle. So that means that we would rotate all the way over here, and we would stop at this point. This is t is equal to pi. This point, being -1, 0, is the terminal point determined by t is equal to pi. Now this is pi radians of this angle, but we're not talking about radians right now because that'll be chapter 6. We only went over the first couple sections of chapter 6 so that we could better understand the unit circle, which will be coming up in the next video. Suppose instead we had t is equal to pi over 2. That would mean we could move along the unit circle here, pi over 2. That would be 0, 1, the terminal point. Now, if instead we had t is equal to -pi over 2, we would move the same distance, but we move in the clockwise direction instead of the counterclockwise direction, because we have a negative value. Move down this. And we come to the point 0, -1. And this is the terminal point associated with t is equal to -pi over 2. We can do this for any t value, any real number. But there are some special ones that we need to talk about. Specifically, pi over 6, pi over 4, and pi over 3. Recall, radian measure is the distance along the unit circle starting at the point 1, 0. Now, we didn't define it that way, but we defined it using a circle of radius 1, and we started on the positive x-axis. So we can put 2 and 2 together and say we were starting at the point 1, 0 if we center that circle at the origin. And then we had sine of the angle theta is equal to opposite over hypotenuse. Cosine was adjacent over hypotenuse. And tangent is opposite over adjacent. Now, you can remember this by using the SOHCAHTOA. This is a mechanism to help you remember which ones go with which. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Another one that I really liked, as an acronym, some old hippie caught another hippie tripping on acid, was another one that I really enjoyed. But remembering that these are the ratios for sine, cosine, and tangent, let's look at the unit circle. Here. And we're going to talk about specifically pi over 6, pi over 4, and pi over 3. So if we'll rotate these 3 different colors, so we have pi over 3, pi over 4, pi over 6. We want to find the terminal points of each of these radian angles. Right? So what I'm going to do is I'm going to show you how to think about this. Remember, pi over 3 is the measure of the central angle. This is the terminal side, and this is the initial side of this angle. So we're measuring this angle here. Now, if we create a triangle, a right triangle, here, we can see that this central angle is pi over 3, and it's an angle on this triangle. So if we look at this opposite side divided by the hypotenuse, if you don't remember what the length of the hypotenuse is, it's 1. Remember that the radius of this circle is 1. So going from the center to the edge of the circle is always 1 unit. So we would have opposite over hypotenuse. So this side right here, the y value specifically, is going to be given by the ratio sine of theta is equal to the opposite side over the hypotenuse. Remember, the hypotenuse is 1. The angle theta in this case is pi over 3. So we have sine pi over 3 is equal to y divided by 1. But what is sine pi over 3? Because y divided by 1 is simply y. That's this y value of this point. Remembering that when we try to plot a point, we go over x and up y. So the y value here is going to be exactly sine of pi over 3. Sine of pi over 3 is root 3 over 2. So we get this. So this side of the triangle is root 3 over 2, meaning that the y value of the terminal point here is root 3 over 2. Similarly, the x value will be cosine, because it's the adjacent side of the triangle. Here, we're trying to relate the adjacent side, the hypotenuse, and this angle that we know is pi over 3. So we get cosine of pi over 3 is equal to the adjacent side. We can call that x because it's the x value of this coordinate, divided by the hypotenuse, which of course is 1. The cosine of pi over 3, as we discovered in a previous section, that's going to be 1/2. Now you'll need to memorize these, but I'll show you how to do it in the next video, so don't worry about too much if you don't remember that this is 1/2. Cosine of pi over 3 and sine of pi over 3 is root 3 over 2. We'll talk about how to memorize that in the next video. So we can say the terminal point, p of x, pxy, is equal to 1/2 root 3 over 2, and this point is associated with t is equal to pi over 3. So with the t value pi over 3, i.e. the radian measure, we get the terminal point 1/2 root 3 over 2. The red one. Now, let's look at pi over 4. With pi over 4, we can make a triangle, again, just like we did before. Then we have this angle here is pi over 4. So if we do the same thing, the y value is going to be exactly sine of theta, in this case pi over 4. That's the y value. The x value is the adjacent side of this triangle. So it's cosine of pi over 4, because cosine relates the adjacent side, the angle, and the hypotenuse. And that's going to be x. And the terminal point associated with pi over 4 will be root 2 over 2, root 2 over 2. And as I stated, that's associated with t is equal to pi over 4. Now the third one I'm not going to do, but you do it the same exact way. I'm just going to give that one to you. You should do it on your own just to make sure that you understand exactly what we're talking about here. So the adjacent side x will end up being root 3 over 2. And the opposite side of the angle is the y value, which will be 1/2. Again, this one's associated with e is equal to pi over 6. These are the terminal points for these three t values. Now, throughout this chapter, we're going to use mostly just the terminal point and t values to get points on the unit circle, instead of describing it as radians. But it is the same thing. Find the terminal point determined by t equals 5 pi over 6. Ooh, this one is interesting. We have our unit circle. I'm going to go ahead and recall that the terminal point associated with t equals pi over 6 is the point root 3 over 2, 1/2. That would be this one. Okay, that's not the one we're looking for. We're actually looking for this angle. We're looking for this t value here. Okay, now what I want you to do is think about this a little bit logically. Don't try to figure out this algebraically. Don't try to calculate anything. Just look at the picture, just for a second here. Notice the y value of both of these points. The y value is actually the same. So when we look at this terminal point, we have a point xy. But the y value is the same as the y value of this point. They're the same height. So we know that the y value of this terminal point is going to be the same here as the y value here at pi over 6. So we know that the y value is 1/2. Purely by looking at the y value of this point and recognizing that they are at the same height. They have the same y value. So what's the x value then? Well, that's actually not too hard to find. If we remember that x squared plus y squared is equal to 1 is the equation of the unit circle, we can just plug in our y. We have x squared plus 1/2 squared is equal to 1. 1/2 squared is 1/4. Subtract that over, and we're going to get 3/4 on the other side, so x squared is equal to 3/4, which means x is going to be either equal to square root 3 over 2, or x is equal to negative root 3 over 2. Now, look at the picture again. Is our x value going to be positive or negative? Keeping in mind that this is in the xy plane, so when we plot a point, we are plotting it exactly how we would plot a point in the xy plane. We move left, we have a negative x value, and then we go up 1/2. So we can say then that the terminal point here is negative root 3 over 2, 1/2. And this is associated with t is equal to 5 pi over 6. In the next video, I'll also show you how to figure out where each of these t values are located. They're going to be the radian measures as we move around the unit circle. I want you to try one like this. Find the terminal point determined by t is equal to 2 pi over 3. You're going to do this one exactly how I did it, except 2 pi over 3 is here, and you have the pi over 3 that you should know already from previous lectures. The next topic I want to talk about is the reference number. Let's start with what a reference number actually is. Let t be a real number. The reference number t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So what does this mean? And why is it important? Reference numbers are actually pretty important. We just don't acknowledge them that much. They're sort of important behind the scenes. So suppose we have a t value. Now this t value has a terminal point here, pxy. We move along the unit circle, p units. And here's our p value, or our terminal point, pxy. So what is the reference number? Well, the reference number, t bar, is going to be the shortest distance along the unit circle from the terminal point to the x-axis. So we are trying to get from the terminal point to the x-axis, but we have to move along the unit circle. So either we move this way, clockwise, or this way, counterclockwise. Which one is shorter? Well, obviously in this case it's the second one. So we would move this distance to get to the x-axis. This distance is going to be t bar. Now, I will note that t bar is always going to be less than or equal to pi over 2 and greater than or equal to 0. T bar is always an acute angle, and that's its importance. It is an acute angle so that we can make a triangle. Show you what I mean here. So, suppose that we want to find the x and y coordinate of the terminal point. Now previously, we found the x and y coordinate using triangles and the sines and cosines to get our x and y values. Okay, but in order to do that, we need an acute triangle. We need our angle here to be less than 90 degrees. So that's the purpose that this reference number serves. It gives us an angle that we can create a triangle with. For instance, if I tried to create a triangle here for t, this doesn't make sense. It's not a right triangle. Therefore, the sines and cosines don't have their normal ratios. We would need to make this a right triangle somehow, and that's not really possible. Unless we draw a straight line down here. But then we're not really looking at t, are we? This angle, which would be t radians, is not really helping us here in this triangle. So instead what we do is we find a reference number, t bar, to give us an acute angle so that we can make a right triangle and find the x and y value using sines and cosines. And obviously a little bit of logic. Okay, so back to what a reference number is. It's the shortest distance along the unit circle to get to the x-axis from the terminal point that's determined by t. So we move here. Now in each quadrant, we're going to have different values. But let's go ahead and do an example first, and then we'll move into what each of them are. Find the reference number associated with t equals 6 pi over 5. Okay, well, first let's look at what 6 pi over 5 looks like. We draw our unit circle. And remember that half of the circle is pi radians. So pi is here. Is 6 pi over 5 bigger than pi or smaller than pi? Actually 1/5 bigger. So what I want to do is I want to divide this pi units into 5 equal parts. We would have 1, 2, 3, 4, and 5. These are equal parts. So this would be right here, pi over 5, or 1/5 of pi, because it's 1/5 of the way around the top half of the circle. So it's 1/5 of the pi radians that we need to get to the first half of the circle. So it'd be 2/5 pi, 3/5, 4/5, and 5/5 would be here. Now if we go one more, we would get to 6/5, be about here. Now 6/5 pi is the same thing as 6 pi over 5. You just multiply the pi to the top of each of the fractions, and you would have whatever pi divided by 5 you're looking at. So 1, 2, 3, 4, 5, 6. 6 pi over 5. Now, what would the reference number be that's associated with this? Remember, the reference number is the shortest distance along the unit circle to the x-axis. So it's either this distance or this distance. Clearly, in this case, it's the red distance. So how far beyond pi is 6 pi over 5? How much more is 6 pi over 5 than pi? That's what we're saying here. If this distance is pi to get to this point, how much more do we need to go in order to get to this point? That's just pi over 5. We can look at it as 6 pi over 5 minus pi. And this will give us 6 pi over 5 minus 5 pi over 5. So it gives us a pi over 5 as our reference angle. Right, now what I want to do next is I want to show you how to find the reference number for a t-value in each quadrant, because each quadrant is really different. And that's all that really matters, is the quadrant and the fact that it's between 0 and 2 pi. But first, we need to draw out a few unit circles so that we can all be on the same page about where certain values are. Okay, so first things first, t equals pi over 2 is right here. This distance from this point to this point is pi over 2 radians. Also just pi over 2 units, because it's the unit circle, has a radius 1. Pi, everyone should know already, that's this distance going from the point 1, 0 all the way around to the point -1, 0 is pi radians or pi units. This distance coming in this direction is 3 pi over 2. You have pi over 2, half of pi. Another half of pi would give us pi, and another half of pi would give us 3 pi over 2. And to go a full circle around from this point to this point is, of course, 2 pi. Now these are important for the quadrants, to divide up the quadrants using a t-value. If you've forgotten what quadrants are, you have your first quadrant, second quadrant, third quadrant, and fourth quadrant. Anything where x and y are both positive, that's the first quadrant. X is negative, y is positive, second quadrant. X is negative, y is negative, that's the third quadrant. And the fourth quadrant would be where x is positive but y is negative. So if we're in quadrant 1, then what would our reference angle be? So suppose our t-value lands in quadrant 1 somewhere. We have our pxy, our terminal point. We need to figure out, this is when if t is between 0 and 90, then we're in the first quadrant. Now if t is equal to 0, that means we're on the x-axis, so the reference number would be 0. If t is equal to pi, that would mean that is also on the x-axis, which would mean the reference number is 0. Now 90 is the degree. I want to use radians, so between 0 and pi over 2. We're in the first quadrant. Here, we have two possibilities. Either we travel this way, or we travel this way to get to the x-axis. Remembering that the reference number, we have to travel along the unit circle. The red is shorter, so the red one is what we're going to use. And that's the same distance as t. Remember, t is the distance along the unit circle to get to the terminal point. So here, t bar is equal to t. Suppose now we're in quadrant 2, though. Suppose we're in quadrant 2. That means that our point lands between pi over 2 and pi. So our t value is here. We travel along the unit circle t units, and that t units puts us in quadrant 2. So our t is going to be between pi over 2 and pi, because pi over 2 is straight up and pi is straight to the left, and we're in between those two. Now, what would our t value, what would our t bar be? What would our reference angle be? What would our reference number be? So we either have this distance, this blue distance, or this red distance. Which one is shorter? Here, the blue distance is shorter. Okay, so how do we figure out what the blue distance actually is? Remember that this is pi units. So t plus t bar is going to equal pi. So we know that t plus t bar is equal to pi. We can see that in our picture. I want to solve for t bar because that's what I'm looking for. So we get that t bar is equal to pi minus t. That will be the value of t bar. So I'm going to erase this, move this over. That's how you find t bar when t puts you in the second quadrant. What if we're in the third quadrant? So our unit circle will now like this. And we have our point here. We go all the way around units where t is greater than pi, but less than or equal to 3 pi over 2. What would we do in this case? Now again, remember, we're trying to get to the x-axis, not the y-axis, the x-axis. So we either go this distance here, or we go this distance here. We go along the unit circle to the x-axis. So we have two possibilities, either red or blue. And in this case, it's going to be blue, or it's going to be red. In this case, it's going to be red. So this is my t bar. Now again, halfway around the circle is pi. T goes from this point all the way around to this point, pxy. T goes from here all the way around to this point. Pi only goes halfway around the circle, and this red goes the rest of the way to t, the t units that we need. So here, what I'm saying is, if we add pi to our reference number, we get our t value, our original t value. And we can figure out what the reference number is from there. We would say pi plus t bar is equal to t. Now I want to solve for t bar, the reference number. We subtract pi over, and we get that t bar is equal to t minus pi. And that's how you find the reference number when it's in the third quadrant. We want to go this distance from the terminal point to the x-axis, moving backwards in this case. Again, t bar is always positive, so moving backwards doesn't make it negative. There's a little bit of nuance in that. What if we're in quadrant 4? So now our point is here. We're moving all the way around. This would be our t value, going all the way around to this point, pxy. So again, we have two choices. Travel backwards to the negative x-axis, or we move forward to the positive x-axis. Which one is shorter? The shorter one is going to be our reference number. Our reference number in this case is going to be towards the positive x-axis moving forward. So hopefully you can see that t plus t bar will give us a full circle, which is 2 pi. Here, remember that t is going to be strictly greater than 3 pi over 2 and less than or equal to 2 pi. But t plus t bar is going to be equal to a full circle, which is 2 pi. So we have t plus t bar is equal to 2 pi. And again, in order to find t bar, we subtract t over, and we get this. To figure out t bar, when t is in quadrant 4, you subtract t from 2 pi, and that will be your t bar. Right, I want you to try a problem. Try one on the accompanying worksheet. Find the reference number associated with t is equal to 7 pi over 4. Now there's one other type of reference number problem that's probably the most difficult, but if you really think about it, it's not too bad. Really, it falls in line with coterminal angles. Find the reference number associated with t is equal to 29 pi over 5. So how do we figure this one out? Well, the problem isn't that it's not solvable. The problem right now is that our t value is not between 0 and 2 pi. It needs to be between 0 and 2 pi in order to use these equations. So how do we find a coterminal angle so that our t is between 0 and 2 pi? An angle that's coterminal that's between 0 and 2 pi. Well, what we're going to do is keep subtracting off a full circle in order to get a coterminal angle. So 29 pi over 5 minus 2 pi. This will be an angle that's coterminal with 29 pi over 5 because it'll land on the exact same point. Now, 2 pi is equal to 10 pi over 5, so we would have 29 pi over 5 minus 10 pi over 5, which is equal to 19 pi over 5. Is this between 0 and 2 pi radians? No, it's not. We find another angle that's coterminal with 19 pi over 5. So we subtract off a full circle again, 2 pi. And again, 2 pi is the same thing as 10 pi over 5, so we would end up with 9 pi over 5. This angle, and this angle are all coterminal angles. They all stop at the exact same point on the unit circle. It's just how many times do we go around before we stop at that point. And in this case, 9 pi over 5 is between 0 and 2 pi. It's actually in the fourth quadrant. 9 pi over 5 is right about here. So because it's in the fourth quadrant, we do t bar is equal to 2 pi minus t. And our t, in this case, we're going to use 9 pi over 5, not 29 pi over 5. Remember, 29 pi over 5 is coterminal with 9 pi over 5, so it's the same exact terminal point. And when we are looking for a reference number, we're going from the terminal point, not necessarily the t value. We do t bar is equal to 2 pi minus t, and we use 9 pi over 5. So we have 2 pi minus 9 pi over 5. So t bar is equal to 2 pi over 5 in this case. All right, that's going to be it for this section. I will see you all in the next lecture.